Hello, fourth graders. Today we get to learn about something awesome called perpendicularity, or what is the definition of a line segment or lines that cross one another or meet at a vertex that make 90-degree angles. So here I've written for us some words that we need to become familiar with. And the first word you see is perpendicular. So we want to define what is perpendicular and what does that mean in terms of lines. So keep in mind there are two types of lines we've talked about so far. One is the line segment, and the other is the line, which we know goes infinitely on in space in the directions of the left and right side of that line. So that's the first part we have to keep in mind. Well, perpendicularity, what does that represent? That means when we have, say, 2 points, and say we would connect them. Okay, and let's make those dots larger. And then we have another line that might cross, and that would have, say, these 2 points. Okay, so when something is defined as perpendicular, that means that they have a cross section of 90 degrees. So if we were to measure from here to here, that would be 90 degrees using our protractor. And then where else might we see another 90-degree curve? Well, on the other side of, we call it the mirror side or symmetry. So the opposite side, we see it again at 90 degrees. Mathematicians, they like symbols, and they also like abbreviating. As you know, Mr. Mod did that a lot in classes. She used shorter ways to explain information because we want to keep it simple and clear. So if you create a box, and I'll go ahead and do that in red, you could see contrasting wise that that means that these two angles on both sides of this line are perpendicular. So the important part here is we label, say for example, A, B, C, these points, and I'll go ahead and label that to D. We see that we can make a statement. We can actually prove or make a statement about these lines or this diagram that we're looking at. So let's see what we can say is true here. We could say right now that line AB, that's line segment AB, is perpendicular, and this is the symbol we want. You see how that looks just like where AB meets with line BD. So if we were to say that all in one sentence, this is a explanation of what we're looking at here is line segment AB is perpendicular to line BD. Okay, and this whole thing right here implies that it's perpendicular. Okay, so that is a symbol. It looks like an upside down T, maybe you might think of it that way. Okay, so just the same, we could say line BC is perpendicular to line BD as well. And then you can make other observations as well here, but we're looking specifically for this 90-degree value of the measurement. And again, you can check that with your protractor to see if that is true when you look at shapes. So that is a right angle. Before this lesson, you also remember up here on the top, I abbreviated some terms for us ahead of time and said 90-degree right angle. That seems redundant or repetitive because 90 degrees already is the same as a right angle. Okay, so they are equal to one another. And then a symbol that you might see besides this little square at a vertex point, right? That's a square of a vertex point. That symbol in red is saying that it is, again, a 90-degree angle. Okay. All right, so here we're on lesson 3. Our target or objective is to be able to identify perpendicularity, or things that are perpendicular, using common objects that are familiar to us that we live with. So on number one, it says, on each object, trace at least one pair of lines that appear to be perpendicular. So you're not necessarily using a protractor here, because the word, they are using your eyes basically, that appear, okay? And they are perpendicular. So we're looking for that 90 degree based on our past experience on the lessons, and also what recommended using a protractor beforehand. So let's look at it. We're going to use that symbol and identify and then circle those things that are. Okay, so I'll stick with red, and then we'll look for perpendicularity. So number one, let's look at these rays that are starting at a vertex point, and we notice it's here on the right here. This is that vertex point of all these different rays, and we can see that this would be considered 90 degrees. So I'm just going to go ahead and draw that little square. The next one with this brick wall, we could zoom in, and clearly there are many vertex points where two line segments meet. So we might want to point out a couple of them. One might be here. There's all four of these are considered 90 degrees. So those are all perpendicular. And then if we look even closer, every single brick here has four perpendicular lines that form perpendicularity. Okay, so that's possible. We can go over here to a clock, and there we are. We can identify between the hour and the minute hand perpendicularity. The sheet of paper here, do we see anything perpendicular? Oh yeah, look down here, there's something perpendicular. Okay, so, up here in these corners, maybe hiding up here as well. All right, there's a fence. I think you get the idea now. Either in the fence or in the area of absence, you can see perpendicularity. So here, there might be something here, some area that we may not have seen it before. More or less, I can just see it in the empty spaces, right? Okay, so you can see it occurring in many areas. And then this one's interesting, the kite. Well, there are two line segments that actually create a plus sign or a cross. So because we see that, I want to just point it out. We're going to see this occur in future lessons possibly. We can see that there are many perpendicular callouts here. So all those create perpendicularity, 90 degree angles. This one's interesting. Are there any things in this polygon? I don't see anything. I don't see anything offhand. If you were to take a protractor, it probably would find out that most of these angles are obtuse, and then there's possibly, maybe, if you want to call it, this could be close, questionable. Maybe you can check that for me. Is that one considered perpendicular? This one looks to be possible also, question mark. So check with your perpendicularity with your protractor. All right, for those sports fans out there, where are the perpendicular angles? And we can see that they're in the stitching. So there's one there. We can see they're just basically throughout that stitching. One thing that we should notice clearly is anytime you see something that has a curvature or has a roundedness, like the clock and the football, and maybe even the notepad with the rip out section, you can't have perpendicularity because it isn't a line in the sense of straight lines. It's not a line segment, but it does have a circular or curved line. So keep in mind, that's something for later. All right, number two, how do you know if two lines are perpendicular? So you define that. Well, what would you think? Think to yourself, take a moment. Okay, so you can define it simply as two lines form a 90 degree angle, and that are perpendicular Okay. Two lines form a 90-degree angle that are perpendicular. Okay, so essentially you can see that throughout this lesson. 3. In the square and triangular grids below, use the given segment in each grid to draw a segment that is perpendicular using a straight edge. Okay, your straight edge, again, is you can use your protractor, the bottom non-curved side, and that's a ruler essentially. So what do you want to do? You want to look at these two grids, so this one first, and you want to use your straight edge, so your ruler, to make perpendicular occurs. So we'll go ahead and say we can do something like that. That would be considered perpendicular. We can create something like that. Let's make that a little bit better. Okay, looks a little bit close, maybe that's obtuse, but so the idea is you want to finish off your using your straight edge perpendicular points. It can be anything, right? There's something perpendicular, and then label them. Don't forget, go ahead and label them. So if that were truly perpendicular, then that would be it. I'm eyeballing it right now, and so that's the idea you want to draw. How about this one on this triangular grid below? Are there ways to show by drawing a segment, a line segment, perpendicularity? Oh, absolutely. Using line segments, we can use them as our guide and create perpendicularity there, right? So that's perpendicular. Anything else? This looks, your eyes can get real busy. Well, you can just create perpendicularity at any point. Maybe even make an enclosure. Okay, so that could be possibly, and this is not perfect. I realize I'm not using my protractor here, but you can show. Yep. Let's just say that was a rectangle, right? Okay, great. So there are many ways to demonstrate what two line segments or can create a perpendicular angle. Okay, I've chosen a few here to look at. I don't want to do them all because I want to give you the opportunity to practice them in both the problem set and homework. But these ones represent the bulk, the majority of them. So using a right angle template, again, you can use your protractor, or if you have created a template that's in the lesson, you can use that as a match. You want to create figures to determine whether they have right angles from these. Mark each right angle with a small square, just like we've been doing. And for each right angle you find, name the corresponding pair of perpendicular sides. So looking at A, first of all, they've done that for us for one example. And there are many more. All the other sides are considered perpendicular as well. So let's look at that. Okay, so we can see that there's perpendicularity here, here, and here. So how would you call that out? You could say, they said AB is perpendicular to BD, line segments, right? You could also say BD, line segment, BD is perpendicular to CD, line segment CD. Same thing, CD is perpendicular to AC. Okay, so there are different ways you want to call each one of those out. And anything else that we missed? We have AC and AB, right? AC, line segment AC is perpendicular to line segment AB. Okay, another one, let's take a look at C. There's we call that a triangle, don't we? It has three sides. And are there any area that could be considered perpendicular? If you use your protractor, I bet you can identify that this is indeed perpendicular right there. And so you would say line segment EF is perpendicular to EG. And do you see anything else? No, I don't see any other perpendicular. The other two angles, these two, probably the same degrees, are acute angles. So let's use our previous math vocabulary. Okay, here we go with D. I bet you'd recognize that this is an oval and there are no line segments. So that because there's no line segments, there is no possibility for perpendicularity. So I'd say perpendicularity, none. Okay. E, we can find out there are plenty of perpendicular areas on this. So they all form 90 degrees. All are, so we'd have to call them all out, right? So AZ, perpendicular to ZF. Again, you could easily call that FZ. It's your choice. AZ is perpendicular to AW. AW is perpendicular to WF. And WF is perpendicular to, let's call that ZF, just to stay consistent. Okay. And anything else? The more or less, you can look at the same other shapes, and it's your turn to have some fun there. Okay. All right. I'm gonna choose to do number 5 because I think that covers the majority of it. So mark each right angle on the following figure with a small square. Okay, because the small square represents a right angle. A right angle does not have to be inside the figure, so they're giving it away. And how many pairs of perpendicular sides does the figure have? All right, so we can confirm that. We're going to go ahead and use red again. And here they all are. There's one there. There's one there. Any place that a line segment and another create a vertex that is 90 degrees would be considered perpendicular. Okay, so you call that out, and then you could check to confirm that those are all true and if there's anything missed. So the primary purpose of this lesson is to determine what sides are perpendicular to each other. So number 6, what do you think? True or false? Shapes that have at least one right angle also have at least one pair of perpendicular sides. Explain your thinking. So can you come up with a shape that has at least one right angle in it? And if so, do they have one pair of perpendicular sides? Okay, so by the very definition of what a right angle is and what perpendicular sides means, what do you think the answer should be? Okay, so again, we read it. We want to draw some kind of shape to represent what a right angle looks like. So if we drew just a standard right angle, okay, make sure they connect. Label it. Oops, that doesn't look okay, better. And then can you close that shape off, because you can't have an open area in a any particular line segment, but shapes, that's the key here. We have to make sure it's a shape, right? So can you think of a way to create a shape that at least one pair, that means 2 line segments or 2 lines, are perpendicular? And the answer obviously is true, because at least 2 in any given shape would be considered 90 degrees and perpendicular. Okay, so it doesn't matter, even if you did a baseball, like a home plate or a baseball diamond or something like that, or you were to create another shape like that kite shape, or you were just to close it off, it doesn't matter. There's going to always be perpendicular sides